He was once known as the boy who shocked the world, the Mars boy, Boriska. Years ago, facing the camera, he revealed a startling secret. In the distant past, Mars was home to a highly advanced civilization. Back then, Mars was not red, it was vibrant and alive, much like Earth. But later, a catastrophic global disaster stripped away its atmosphere in an instant. The survivors were forced underground, building vast subterranean cities. Setting urban legends aside, two recent scientific discoveries have, to some extent, unexpectedly supported the idea that Mars once harbored life before suffering a great catastrophe. It was not an interstellar war, but a cosmic law far more ruthless than war itself. If such a disaster could destroy Mars, could it one day descend upon Earth as well? Hello, Earthlings. I'm Lao Ma, and once again, I'll need you to journey back, this time to Mars 4.5 billion years ago. You will witness how this planet transformed step by step from a blue paradise into a red hell. And the key to uncovering the truth lies hidden inside an unremarkable rock. Let's drag the timeline all the way back. You are now floating in space. Look over there. That is Mars, newly born. At this stage, Mars and Earth were like twin brothers, both formed from the same massive rotating disk of dust and gas surrounding the young sun. Countless fragments of rock collided and, under gravity's pull, merged into a sphere with a dense core, rocky mantle, and crust. Mars now enters the pre-Noachian era. If you tried to land here, you'd better wear the thickest protective suit imaginable. The planet has just formed, and the surface temperatures are extreme, like a giant steel furnace. The sky is filled with chaotic debris as this young world is relentlessly bombarded from space. But this is only the beginning. As time passes, around 4.4 to 4.3 billion years ago, Mars begins to cool. Picture the scene: molten magma solidifying into black rock. Water vapor in the atmosphere condenses, forming the planet's first rain. This rain lasts for millions of years. Eventually, a vast ocean appears on Mars. Scientists believe it was enormous, covering the entire northern hemisphere, nearly 1/3 of the planet's surface. Standing on that ancient Martian shoreline, you might not know whether you were on Earth or Mars. Waves crash against black volcanic beaches. In the distance, volcanoes erupt endlessly. This Mars is not yet paradise. It's more like an unfinished house under construction, dangerous, yet full of potential. Time flows onward. We arrive at 4 billion years ago, the Noachian era, the most critical and the most captivating chapter in Martian history. Asteroids and comets strike from time to time, triggering massive explosions. But for life, this chaos is actually a gift. Why? Because impacts and intense volcanism release huge amounts of gas, water vapor, and dust into the atmosphere. It's like wrapping Mars in a thick blanket. This blanket creates a powerful greenhouse effect, trapping the sun's heat at the surface. Mars begins to warm. And not just warm, its atmosphere becomes thick and dense. Standing on the surface now, you'd see skies filled with clouds. Massive rivers carve through valleys. Lakes appear everywhere. Rain falls from the sky. But beware, this rain is acidic. To us, acid rain is a disaster. To early microbes, it is a miracle. The acid dissolves rock, washing minerals and nutrients into rivers and lakes. For primitive life trying to emerge from non-living matter, this is a free chemical buffet. Now consider Earth at the same time. It was going through a similar phase. Some scientists even believe that early Mars may have been more hospitable to life than Earth. This leads to a tantalizing question. Did life already exist in those ancient Martian oceans? Not intelligent talking Martians, but under a microscope, were those waters already teeming with wriggling single-celled organisms? Let's return to the present. What did NASA's Perseverance rover discover? At the time, Perseverance was exploring Jezero Crater, a site of enormous importance. Billions of years ago, this was once a massive lake. A powerful river flowed into it, forming a perfect delta. The rover entered an ancient dried river channel called Nerit Vivalis, It was once 400 meters wide with raging currents. Here, scientists discovered a strange piece of red mudstone. It was covered with eerie spots resembling leopard patterns. Analysis revealed iron phosphate and organic molecules. Here's the key point. On Earth, when we find this exact pattern with this specific chemical composition, it usually means one thing. Microbes once consumed organic material in the rock, leaving behind chemical reaction traces. We'll need to return samples to Earth for absolute confirmation, but this may be the strongest evidence yet that microbial life existed on Mars billions of years ago. Imagine this moment. 3.5 billion years ago, Mars is cooling, but near Jezero Lake, in one of the last green oases, you wouldn't need a bulky spacesuit, just an oxygen mask. You bend down, scoop up a handful of lake water, place it under a microscope, and see countless tiny lives swimming. This is the final afterglow of Martian life. If history had followed this path, Mars could have evolved complex animals, perhaps even intelligent civilizations, but the universe shows no mercy. Between 4.1 and 3.7 billion years ago, Mars received its true death sentence. The great disaster spoken of by the Mars Boy has a cold scientific name: magnetic field collapse. You need to understand this. A planet can only retain its atmosphere if it has a magnetic field acting as a shield. Mars is smaller than Earth, so it cooled much faster. During that period, deep inside Mars, the planet's massive internal dynamo, its liquid metal core, began to slow. Convection weakened. The heart stopped beating. This did not happen in an instant, but on a geological timescale, it was an irreversible collapse. Mars's invisible shield failed. It was like standing in a battlefield when your bulletproof vest suddenly loses power. The sun, the star that gives life to everything, now revealed its cruel side. The solar wind, a torrent of high-energy charged particles, began to bombard Mars relentlessly. Without a magnetic field to deflect it, the solar wind became countless microscopic scalpels, slicing directly into the Martian atmosphere. It was a slow execution. Over the endless ages that followed, every second, tons of atmosphere were blasted into space. Layer by layer, Mars's atmosphere was stripped away alive. Atmospheric pressure plummeted. Without insulation, the liquid oceans first evaporated, then what remained froze solid until surface water vanished entirely. Mars transformed from a warm greenhouse world into a cold, dry, radiation-soaked wasteland. So what about the life that had just begun? It faced a brutal choice. The surface had become hell. Intense ultraviolet radiation could sever any DNA strand. Extreme cold could shatter any cell. To survive, there was only one option: go down. This is the chilling coincidence at the heart of the Mars Boy legend. The survivors were forced to live underground. Scientists believe that if Martian life did not go extinct, it must have retreated into subsurface aquifers, deep caves, or regions near volcanic heat where geothermal energy could sustain it. In 2025, a study published in Nature confirmed something remarkable. Liquid water does exist beneath the Martian surface. And perhaps even today, within those hidden underground waters, microbial life may still be quietly reproducing, remembering the vanished oceans of 3 billion years ago. Who can say for certain that life is not still lurking there? Even then, Mars seemed unwilling to give up completely. For hundreds of millions of years afterward, the surface was already a desert, but the planet had one last breath left: volcanoes. Look at that mountain. Olympus Mons, the tallest volcano in the solar system. It rises 21.9 kilometers high, covers 280,000 square kilometers, equivalent to stacking 2.5 Mount Everests on top of each other. Why doesn't Earth have mountains this tall? Because Earth is still alive. Its tectonic plates move. Mountains are displaced before they can grow too large. But Mars is dead. Its crust no longer moves, so lava could erupt in the same place for hundreds of millions of years, piling up again and again until this monster was formed. Long after Mars had cooled, Olympus Mons still erupted from time to time. Each eruption was a dying planet's struggle. Lava brought brief warmth, melting nearby ice, triggering massive floods, momentarily restoring flickers of habitability. But it was only a final illusion. Eventually, around 1 billion years ago, even the volcanoes fell silent. Mars officially entered the Amazonian era, the Mars we see today. Red dust storms swallowed everything. No water, no breathable air, only deathly silence. At this point, you might think this is just the tragedy of a neighboring planet, but let me leave you with a far more unsettling thought. More than 400 Martian meteorites have been found on Earth. They arrived here after asteroid impacts on Mars ejected rock fragments into space, which eventually fell to Earth. We know that 3.5 billion years ago, Mars's localized habitable environments very likely hosted simple microbial life. At the same time, life on Earth was only just beginning, or perhaps had not begun at all. So here is the question. Is it possible that during a massive impact, Martian microbes hidden inside rocks boarded a meteorite, a natural spacecraft, crossed the void of space, and landed in Earth's early oceans? There, in a new home, they multiplied, evolved into fish, into dinosaurs, and eventually into you and me. If the theory of panspermia is true, then the Mars boy was only half wrong. Life on Mars did not fully perish, because we may be its surviving descendants. We are not exploring an alien world. We may simply be returning home. The next time you look up at that red star in the night sky, remember this. It may not be a distant world, but a former homeland waiting to be remembered. Thank you so much for watching Entropy Files. See you next video.